Welcome to this video, and here we are going to talk about force. Now, force is one of the topics in mechanics of physics, and we're going to define what it is. We're also going to talk about how this force affects bodies. We're going to state its SI units, and also we're going to talk about the types of forces. Well, let's start. Now, what is force? Now, force, it can be defined as a pull or a push, or pull or a push of a body. If you pull a body or you push a body, then that can be defined as force. Now, in many instances, we have situations where we pull or push bodies. Now, whenever we pull or push the bodies, then we are applying what we call force. Now, the SI unit of force is given as Newton. Now, Newton, represented by N. Newton is a person who came up with the unit Newton. Now, he discovered that Newton, or a force, can be either represented by mass, can be represented by length, or meters, or time, seconds. And therefore, we're going to, in our preceding videos, we are going to explain how the Newton also can go down or can be reduced to the MKS system, that is the kgs, meters, and seconds. And therefore, force has the SI unit of Newton. Now, force is also a vector quantity. Now, a vector quantity means it has both direction and magnitude. Now, for example, if you talk about a force moving towards a given direction, this is the direction to show that the force is moving to the right, and the F here represents its magnitude. So it could be 10 newtons, 20 newtons, 30 newtons, and so on. And therefore, a force is a vector quantity. Now, what does force do? Now, force can stop a body. So let's say a body is moving with a given velocity or with a given acceleration. That body can be stopped, and therefore what stops it is what we call force. So if you introduce, or if you subject a force on that body that is moving, then you will have stopped the body. So therefore, a body or a force can stop a moving body. Now, a force can also accelerate a moving body. So if a body is moving at a given velocity, say it's a constant velocity, now that velocity, say if it is 20, it can be increased to 30 meters per second. Now, what is going to accelerate it to that velocity? That means, therefore, we have to introduce a force. If a force or is a body is moving, then you add more force on that body, it's going to accelerate, or the speed is going to increase with the time. Now, a body or a force can also deform a body. So if you have a body, say a ball, if you have a ball and you kick the ball with a sharp object, then that ball might deflect, and therefore the shape is going to change, it's going to be deformed. Maybe you can think of a balloon. If you press a balloon is going to burst, or it's going to change the shape, so it's going to be deformed. Or think of the those vehicles that are involved in accidents. Those vehicles, they are in good stature, but the moment they collide with each other, they are deformed, and therefore a force can deform a body, or can distort a body for that matter. Now, it can also change direction of a moving body. So let's say we have a body that is moving towards a given direction. If it's subjected to a force, then it can change the direction. For example, if you think of a ball that is moving towards that direction, and a player has to pass it to another person without stopping it, therefore that person is going to apply some force to that ball, and the ball is going to change the direction it was taking. Well, so that's all about the effects of force on various bodies. And now let's talk about the types of forces. Now, we have so many types of forces that we are going to discuss in our preceding videos. Each of these forces, we are going to discuss them one by one. But in this video, we simply want to just highlight them and know what they are talking about, or what they entail. Now, we have gravitational force. Gravitational force. Now, gravitational force has to deal with a force that tends to pull a body towards the center of the earth. Now, if you throw an object, for example, from a given point, and it's moving towards the ground or towards the earth, there is a force that is moving that body towards the center of the earth. That force is known as the gravitational force. and of course all the forces are represented by newtons. Most of the time we use the acceleration due to gravity as 10 or 9.8 meters per second squared, and therefore here we are going to talk about bodies that are moving in vertical direction. Now when you talk about bodies that are moving in horizontal direction, we don't really include the gravitational force. Gravitational force has to deal with bodies that are moving in vertical direction, because in vertical direction is where we have the acceleration as g, or gravity, the gravitational acceleration, that is a constant, which is about 9.8 meters per second squared. Now also we can talk about tension force. Now let's think about when you are pulling a rope. When you are pulling a rope, or you are hanging something from a rope, now that rope is going to be really tight. Now that body or that string is held by a given force. That force is known as the tension force. Now I want you to think of two springs. If you are holding two springs, one on this hand and the other one on this hand, and then there's a string between the two springs, and you want to pull aside. Now this string is going to feel some force. That force is known as tension force. Now this force that is felt on the strings, for example, if I can draw that. So if you have a spring here, you are pushing or you are pulling to this side, another one to this side, and we have a string here. This string is going to feel some force to this side and some force to that side, and that one is going to be called tension. Or sometimes if you have a lift, for example, that is moving either downwards or upwards, is going to, the string holding this lift is going to feel some force, and that force is what we call the tension. Therefore tension is a force that is felt on a string that is holding a given object, either vertically or horizontally. Remember, before we go to the next one, remember tension. When tension is exceeded, then the string is going to break. For example, think of a very thin string that is holding a 40 kg mass. That mass could be too big for that string, and therefore when tension exceeds, or when tension is exceeded, if say this is 20 newtons and then the tension is 10 newtons, you notice that this is going to be more, and therefore we expect this string here to break, and therefore tension must be greater than the force, so that it can hold the object in position. Now we can also talk about what we call upthrust. Upthrust is a force that is felt in a liquid or a fluid. Now we have a force that is a body can feel when it goes down a given fluid. For example, let's talk about water. If you insert this pen in water, it's going to feel some force upwards, because think of this. If you have this pen, if you throw this pen down, the time is going to take from this point to the ground is not going to be the same if you threw the same pen in water. It's going to take some time. Why? Because in water we have a force that tends to oppose the motion of a body that is moving within the liquid, and therefore upthrust. We talk about upthrust when we deal with fluids or liquids, that is gases and liquids. Now for example, in air, this is air. If I throw this object down, it's going to feel some upthrust due to air. The same time, if I have glycerin and I want to have a ball bearing inside the glycerin, if I throw the same ball bearing on air, is going to take little time as compared to when I throw it in glycerin. Why? Because glycerin has upthrust, and upthrust is represented by U. Now this upthrust depends on the fluid, depends on the liquid that you're talking about. Now if you think of a liquid like glycerin and water, you're going to notice that glycerin has more upthrust than water, because glycerin is denser than water, and therefore we expect it to have more upthrust, and therefore upthrust is a force that is tends to oppose motion in fluids. Now let's talk about cohesive and adhesive forces. Now, cohesive and adhesive forces are forces that are felt in liquids mostly. Now, we have those forces that are felt, or those forces that come as a result of attraction between molecules of the same kind. For example, if you talk about water and another molecules of water, they are going to come together due to the cohesive forces, because cohesive forces means this is the attraction of forces between molecules of the same kind. Now, when you talk about adhesive forces, then it is the opposite of the cohesive forces. Cohesive forces means we are going to deal with the attraction between molecules of different kinds. Now, let's talk about glass and water. Now, glass and water, we might not really have them come closer together because they are different molecules. The molecules of glass and molecules of water are different, and therefore we expect adhesive forces to be strong in glass and water. Now, adhesive forces and cohesive forces explain more about how molecules that are related attract each other, and those that are not related attract each other. We can also talk about frictional force. Now, frictional force is a force that tends to oppose motion on a surface. For example, if you have a force that we have an object that is moving on a given surface, we are going to have the body being opposed by some force. That force is known as the frictional force. Now, frictional force can be reduced or increased depending on the roughness or the smoothness of a surface. If our surface is rough, then it means we are going to have a higher frictional force, and if it is smooth, it's going to have a lower frictional force. Now, frictional force can be either increased or decreased. If you want to reduce frictional force, for example, you want to make your work easier, then among the ways to reduce this friction is greasing, using rollers, and so on. If you want to reduce, then you can do that. If you want to increase friction, then you have to make your surface to be rough, because the moment it is rough, it's going to increase the frictional force. Now, we can also have frictional force within liquids, and that is known as viscosity. Now, in liquids, we have those forces that oppose motion in liquids, and don't confuse between viscosity and upthrust. Now, upthrust is a force felt by an object that is moving or is moving in water or in liquid or a fluid. But now when you talk about upthrust, or we talk about frictional force or viscosity in a liquid, then you're talking about that force that tends to oppose the motion of a body in water. So it's the same frictional force, but in water we call it the viscosity. Now next we have the magnetic forces. Now the magnetic forces forces that are felt within the polarities of a magnet. We have the north poles and the south poles. So these poles are going to feel some force. If you bring a north pole and a south pole together, you're going to have some attraction, and that attraction of those two polarities is what we call the magnetic force. Now, if you bring like poles together, as we are going to see in our preceding videos, you're going to see some repulsion of those polarities, and that is also a force, and therefore this magnetic field that is moving from one polarity to the other is the one that we call the magnetic force. We're going to explain more about the polarities in terms of dipoles and so on. Now, we can also talk about electrostatic force. Now, electrostatic force is almost similar to magnetic force, but now here we're talking about charges. Now, how do charges attract each other, or how do they repel each other? Remember, charges can either be positive or negative. Now, if you have two charges that are alike, or they are positives, both of them, then if you bring them closer together, you expect some repulsion of those charges. Now, if you bring those of different kinds, that is either the negative and the positive together, then you expect them to attract each other, and therefore like charges repel and unlike charges attract. Now, forces due to charges is what we call the electrostatic force. Now, we also have what we call centripetal force. Now, centripetal force is a force that tends to pull an object towards the center of a given circular path. So the centripetal force has to deal with a circular motion or a body moving in a circular path. And therefore, we're going to really talk about the dynamics of the centripetal force. Now, lastly, we have what we call the surface tension. Now, surface tension is also a force. Now, this force is normally felt on the surface of a given liquid and mostly water. Now, on water, we have a force that behaves like a thin elastic skin, and that force can be defined as surface tension. We have so many applications of this surface tension, including the aquatic animals can walk on water, like insects can walk on water because of surface tension. The moment it's broken, then they can sink because we have broken surface tension. You have also ways of increasing surface tension or reducing surface tension, and that includes increasing the temperature will reduce the surface tension, and also adding impurities will reduce surface tension. So that's all about force. We are going to also talk more about force in terms of weight and so on in our next video. But for this, these are the definitions of force, these are the effects of force, and these are the types of force that you can get in physics. So stay tuned. Make sure you follow for more, like this video, and also subscribe.